Hi, this is Arjun from Connext. Today I'm going to be running you through Indra, which is our payment channel hub implementation that is available right now to be used on in production on the Ethereum mainnet. Indra is basically a way to set up micropayments within your ecosystem. So if any user that's connected to your Indra server is able to pay any other user that's connected to your Indra server instantly and for free through payment channels. Setting up Indra is pretty straightforward. You just browse to our repo, clone the repo, and then run these batch scripts. It doesn't take too long, but I've already done it here to save some time. And so once you get that done, it should pop up with this UI. So first things first, it'll prompt you to choose a signer. This sort of goes into how payment channels work. So a quick review: a payment channel is an off-chain trustless payment construction where you are able to pay a counterparty by you first deposit some funds into a contract, and then you send a counterparty signed state updates that allow them to redeem funds from the contract. So the analogy here is like a bar tab. If you go to a bar, you give your credit card, and then you order a bunch of drinks, and then at the end of the night, the bar sort of settles up with you. The reason that we have the ability to choose a signer is because we found that the user experience of signing each and every transaction with MetaMask is actually pretty poor. And so we built a browser-based auto signer, basically like a delegate key that signs all of your channel interactions for you and allows you to just deal with MetaMask only for depositing and withdrawing from the channel. It isn't absolutely necessary to use this, but we do recommend using it because it is a much better user experience. So I'm gonna create a new signer. It's gonna pop up with a mnemonic, and then close. Cool. So this is the channel interface that we've created as a reference implementation of what it looks like to set up an Indra node and do payments through it. You feel free to sort of use this and adapt it to your needs. This is basically meant to just run you through all of the possible pieces of functionality that are available. So over here, you'll see channel information, which will contain balances once we do anything to this channel. There's your off-chain balances available here. You can reselect your signer if you'd like, though if you do this, we recommend that you clear your cache, and then request collateral. So I'll kind of go over what that does later. First things first, let's deposit some funds. So we'll start by depositing 100 Finny, which is like 0.1 ETH. Deposit that in there, and then confirm the MetaMask pop-up. So what this will do is this will actually deposit 60 Finny. One of the part of the way that this implementation works with the auto signer is that the auto signer keeps 40 Finny in order to pay for gas for deposits. This is something that we'll sort of abstract away later. This is just, we've done it this way to save time and make it more simple to use. But the goal is to have that all happen in one on-chain transaction anyway. Cool. So what's happening here is your channel, your front-end client is proposing something called a proposed deposit that gets signed and sent to the hub, and then you make the actual deposit on-chain in the channel, and then the hub sort of waits for the channel for the on-chain contract to mine the deposit, and then confirms the pending deposit with you. So sends back another signed state which confirms that deposit occurred. One thing that you'll notice is that there was no actual opening and closing of channels here. We completely got rid of that because we found that that's kind of a dated construct. What users really want is not to have to learn how something new works. It turns out that they really just want to use something that looks like a wallet, and just being able to deposit and withdraw without having to deal with anything else was really the most effective way to do that. So the way that it works now is that channels are just keyed by your address. In this case, it's your signing address, and then you're able to deposit and withdraw into and out of that address at any time and for any amount. So you can do a partial withdrawal where you need to withdraw 30 Finny out of here if you'd like, and you can also do a deposit while there are other activities happening. So while the deposit was pending, I could have made a bunch of payments and swaps if I wanted to. Cool. So let's start by swapping for some tokens. The reason that we do this is, so the reason that swaps exist is that we found that not everyone will always have the token that you need in order to, like, within your ecosystem. It's actually pretty useful to be able to just give them access to that token within the channel, because that can happen instantaneously and then happen as a part of the tradition, like the normal flow for users. And you can see here that it's just very, very quick and easy. So there we go. That's 100 worth of TST token, which is a stable coin pegged to a dollar. So think of it like as DAI or Booty or USDC right now. We found that like having the ability to do this gives you the flexibility to create your ecosystem the way that you want to. You don't have to do payments in tokens. You can do payments in ETH. You can also sort of deposit in ETH and instantaneously give your users tokens. You can allow them to use both. We understand that everybody's use case is going to be a little bit different, and we wanted to give people the flexibility to do whatever they needed to do. Awesome. So next step, say that we want to pay somebody. So let's open up a new channel here, create a new signer, new signing key, and copy that address. So you'll notice here that this also has balance loading, and there's also kind of an interesting caveat to how payments work. So what's really happening on the back end here is that you have a channel open with the hub, and then your counterparty has a channel open with the hub. And when you pay your counterparty, you're technically paying the hub, and then the hub makes a corresponding payment to the counterparty. The reason that it happens this way is because then from that one same channel that you have open with the hub, you're able to pay anybody else within the ecosystem. And eventually, when you start connecting hubs together, you'll be able to pay anybody else within the entirety of the network. However, one sort of downside of this is that you need collateral in this channel in order to receive the payment. We've sort of realized that in most cases, payments tend to be unidirectional, and like channelized systems tend to be unidirectional. So like there'll be a certain set of senders and a certain set of receivers on Spank Chain system. That's like the viewers and then the performers. And because of that, you can create specialized accounts for like receivers that have the ability to request collateral from the hub. So hubs don't by default collateralize every single channel that you interact in. The reason for this is that you don't want to spam the hub and effectively get it to lock up all of its funds. Instead, you just hit the request collateral button, which allows you to request collateral. And this can be done in your ecosystem. This can be done programmatically when a receiving user logs in, for instance. Once that happens, you'll see that this will update with that collateral, and then you'll be able to plug in the counterparty's address here and pay them. So that went through. Oops. Hello. Interesting. Oh, there we go. So that went through, and then pay TST. So we just made a one-way TST payment. That is 0.0000000000001 $. A really, really small payment. Awesome. And you'll see that shows up instantaneously on the receiver side as well. So we can make a few more payments. Cool. Those happen instantaneously. Now you might be wondering what happens in the event that you haven't actually set up the ability to request collateral on the receiver side. Hubs can be configured to automatically deposit into a receiving channel if a payment is attempted. So if I hadn't actually requested collateral here, I could have just made this payment. The first payment would have failed. The hub would have collateralized this channel, and then the second payment would have succeeded. So that's sort of an alternative, optional way to do it in case that you don't want to have this manual collateralization process. Awesome. Now that we're kind of done with this channel, we can go and withdraw all of our funds. So withdrawal is pretty intuitive. You plug in an address. In this case, we want to withdraw straight to our MetaMask. You generally don't want to withdraw straight to your browser signer because that's just an extra transaction that you have to do. So you can kind of save yourself the hassle here. And then you are able to pick any amount that you want to withdraw. So say that I wanted to withdraw 100-way ETH, so I could withdraw that, and the browser signer automatically signs it, and this reduces by 100-way ETH. And then there's a little bit of an interesting thing here where this button doesn't explain it the best way, but you can also choose to withdraw max. Withdrawing max actually withdraws everything in the channel, and the way that this is configured is that it withdraws everything in the channel and converts it to ETH or into TST. So in this case, we're converting everything into ETH before we exit the system. So everything that you get will be in ETH. And when you hit withdraw here, it'll zero everything out. You might also notice that the hubs TST, the hubs balances were also zeroed out. That's because hubs are sort of configured to automatically attempt to rebalance channels anytime that they can. So with deposit and withdraw, what you're really doing is something called an authorized update. That authorized update can be really anything. So what you can do is you can batch, a withdrawal transaction, a deposit transaction, a swap transaction, and a hubs withdrawal all into one on-chain transaction, which is really, really awesome for user experience, and allows us to do this really cool thing where anytime a user interacts within the channel and does an on-chain, like an on-chain transaction within the channel to deposit or withdraw, they can effectively pay the gas for the hubs rebalancing. And the gas there would be extremely minimal. So you can have like rebalancing happen in a very intuitive and simple way. And that's pretty much it. You can sort of feel free to like play around with this ecosystem. If you find this interesting, we'd love for you to give us your feedback on it, and let us know the sorts of things that you're interested in building. We're an free open source infrastructure project, and so all we really want is for people to use this technology and build really cool stuff with it. So definitely hit us up in our Discord if you have any questions, and thank you so much for watching.